Now in mathematics, you probably have heard of the laws of indices. Okay? You probably sit there and go, oh man, I'll never know this one. Yes, you will, because you got me. And indices really basically focus on exponents. When you just think of indices as synonymous with exponents, okay? Once you hear the word indices, the first thing you should think of is exponents, because there are laws of indices and they have everything to do with exponents. You'll see that in just a second. Alright, indices. Now this is not your indice here. The letter A is not your indice. Your N is your indice. It's also your exponent, okay? Now, when it comes to indices, they're a little more specific, okay? A can be any real number. It can be a negative number, it can be a positive number, it can be a decimal number, it can be a fraction number. It doesn't make any difference. But the N must be a positive integer. We don't want to use a fraction when we're talking about indices in the equation. Okay, so if we're talking about indices, we don't want to have any fractions. Not for your exponent. Your exponent must not be a fraction if you're going to deal with indices. And it must also be positive. You do not want to be dealing with a negative exponent if you're dealing with indices. It's just not going to work that way. Okay? Now, the first law says that if you have a raised to the power of m times a raised to the power of n, you can take the m and the n, you can add them together, and you can raise a to that power, whatever that becomes, and boom. Let me show you how that one works. We have 4 raised to the power of 3, 4 raised to the power of 2. We're going to multiply this times this. Well, let's first raise their powers. 4 raised to the power of 3 is going to be 64. 4 raised to the power of 2 is going to be 16. Well, 64 times 16 is 1,024. Don't believe me? Try it on your calculator. Alright, now let's add the 3 and the 2 together. Well, if you add 3 plus 2, you get 5. So we got 4, which is going to be raised to the 5th power. Well, if you raise the 4 to the 5th power, you're going to get 1,024. Basically, when you raise a number to a certain power, let's say we're going to take the 4 raised to the power of 5 as an example. All right, if you're raising 4 to the power of 5, what you're going to do is you're going to say you're going to multiply 4 times 4 times 4 times 4 times 4. Well, 4 and 4 is 16. 16 times 4 is 64. And let's see. Yeah, it's kind of handy to have a calculator. Let's see. 4 times 4 is 16. Times 4 is 64. Times 4 again is 256. If you take 256 times 4, you get 1,024. Now, if that was too fast for you, I'll go over that again. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256, and 256 times 4 is 1,024. So when you take 4 times 4 times 4 times 4 times 4, you'll get 1,024. End of story. Now, what if you have a couple of fractions here? Okay? A raised to the power of m is now being divided by a raised to the power of n. Well, if you have that situation, you have a, which is m minus n. Let me show you how that one works. We have 2 raised to the power of 3 and 2 raised to the power of 2. Well, 2 times 2 is 4, and 4 times 2 is 8. Boom. 2 times 2, of course, is 4. 8 over 4. Well, if you divide 8 by 4, you're going to get the answer of 2. Alright, let's go over here. We're going to subtract 2 from that 3. See that 3 right there? We're going to subtract 2 from that 3. So, 2 raised to whatever power this is, which is 3 minus 2, which is 1. Well, 2 raised to the power of 1, and automatically it's going to become 2. If you don't believe me, you can check that out on a calculator all by yourself. But anyway, that's a couple of laws of indices. This is kind of how indices work. I'm going to cover the rest of it in my next video. Stay tuned.